Hello everyone, I am Somestra Janapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. In this class, we will solve one numerical on simply supported beam while application of 2 point loads and 1 UDL is there. So, how to solve? As usual, we will just find out the reaction forces, then we will calculate the shear force and then go for bending moment calculation. So, first step 1 is calculation of reaction forces. So, we know that the end supports, at the end supports we will have reaction forces, and also we know that summation of all the horizontal forces is equal to 0 and summation of all the vertical forces is equal to 0. So, here this RA and RB are also forces. Also, we are having 2 point load and the UDL as the vertical forces. So, here we will have RA plus RB is equals to 50 plus 40 plus 10 into 4. You can ask why 10 into 4? As you can see here we are having 110 kilonewton per meter UDL. So, this 10 kilonewton per meter. Here we are having per meter 10 kilonewton load. So, you can see the length is here 4 meter. So, 10 kilonewton per meter will be applied at 4. That's why we will multiply this. RA plus RB equals to 90 plus 40. Here we will have RA plus RB as 130 kilonewton. Okay. While we will go for the calculation of movement. So, how to find out movement? Summation of all the movement is equal to 0 also. So, while calculation of movement, let's see how to calculate that. Here you are having RB multiply with 10. 4 plus 4 plus 2. Your distance, total distance is 10 meter, is equal to 40 into 6, okay, minus 10 into 4 into 2 into 2. Okay. Why? You can see this 10 into 4. 40 kilonewton will be applied at the midpoint. Okay, so distance will multiply this to this. Here 2 meter and also here you are having 2 meter. Okay, so we are calculating here 2 into 2. Then minus 50 into 2, right? So now RB into 10 is equals to 240 minus 4 into 2 to 2, 16 into 10, that is 160 minus 100. Okay. Two 40 minus 160. Okay, 80 minus 100. Here you are having this plus and plus. Okay, no negative signs. So you will have 0, 16, 10, 26, 24. 500. So RB is going to be 500 divided by 10, that is 50. 50 kilonewton. Okay. So here you have RA plus RB as 130. So RA will be 130 minus 50. We will have RA is equal to 80 kilonewton. When we found the RA and RB, that is the reaction forces, our half work is complete. Okay. Now we have the values of reaction forces. You are having RA as 80 kilonewton and RB as 50 kilonewton. Okay. So here you have the RA and RB value. Now our work is to find out the shear forces. Next step, calculation of shear force. So we know that shear force calculation is nothing but first the force at the end support. How to do it? Here. We know the shear force is nothing but your total force. Here we are having 50 kilonewton at point B. So shear force at B will be similar. Force at B is equal to minus 50 kilonewton. Right? Next, shear force at C. Sorry, shear force at D. So here minus 50 plus 40. Shear force at D. Minus 50 plus 40, that is what? Minus 10 kilonewton. Right? Or shear force at C. Here, till now, up to this, we are having minus 10. So, minus 10 plus this, 10 into 4, 40 plus 50. Okay, but we are having minus 10 plus this 40 plus 50. So, we will have 80. You can write minus 10 plus 10 into 4 plus 50. That is 80 kilonewton load. Okay. Now, shear force at A. Already we have that the reaction force at A is 80. So, Newton. Now, we have the shear force calculation and the values of shear forces at different points. Next work is to find out what? Bending moment. What? Bending moment calculation. So, similarly, at these 4 points, we will have calculate the bending moment. We know that at fixed point or fixed end supports, we will have the bending moment as 0. Okay. So here at support B, we will have 0. Then this force 50 multiply with the distance. So bending moment at B is equal to 0. Bending moment at D is equal to what? 50 multiply with 4. This 50 multiply with 4 as 200. You can have kilonewton into meter. Then bending moment at C. So this bending moment at C, we will have which distance? Here bending moment at D. Okay. You have bending moment at D. Now bending moment at C. So first 50 multiply with this whole distance. Okay. 4 plus 4, 8. 50 into 8 minus this 40 into 4. Next what? Next minus 10 into 4 multiply with what? This distance 2 meter. Okay. So you will have 50 into 8 minus 40 into 4. Let's check. Yes, 40 into 4 again minus 10 into 4 into 2. Okay. So here you will have the value that is minus. Okay. Two 40, 400 minus 240. That is 160 kilonewton into meter. Okay. Bending moment at C will be 160 kilonewton into meter. We know that at end supports bending moment is always 0. But here let's check it. Okay. Bending moment at A. Let's check this by using the formulas. So we will have first 50 into 10 minus 40 into 6 minus this 40 into 4 plus 2 again 40 into 4 again minus of what 50 into 2. Okay, let's check it. So 500 minus 3 minus 160 minus 100. Okay, these to this is nothing but 500. Here we will have 500 minus 100, that is 0. Okay, here we have the proof that at end supports we will have the bending moment as 0. 0 kilonewton per meter. Okay. Now we have all 4 bending moments and all 4 shear forces. So let's draw SFD and BMD. So when we only have the point loads in case of simply supported beam, we just always draw line. But while we have the UDL, there will be some changes in case of SFD and BMD. Okay. So at point B, we have shear force as what? Minus 50 minus 10, 80. Okay. So here as negative, so minus 50 is going to be here. Okay. Then at point E, we are having the value that is minus 10 kilonewton. Okay. 80 kilonewton and this 80 kilonewton. Let's join this. So we will have the shear force diagram like this. Sorry. Uh, okay. Here this is minus 80 and minus 10, as I have already said. This point is having what? UDL. So the diagram is going to be like, okay. Here is the area for shear force. This shear force diagram. Okay. Next, go for BMD. So in this point, we are having 1, 0, and here also 0. So let's check at point C and point B. Here we are having 200 and another is 160. So let's take this point as 200 kilonewton per meter into meter and this as 160 kilonewton per meter. These to this are also is going to be your line. This will be joined by line, but this is going to be your arc. Okay. Here is your diagram for PMD. Okay. So in this class, we have learned how to find out shear force and bending moment for while application of 2 point loads and 1 UDL is there. In our next classes, we will solve a lots of numerical. So stay tuned. Thank you so much.